When trying to bridge the gulf of evaluation, we're trying to help users understand the state of the system. And so let's talk about a few tools to help them do that. One of them we've already talked about quite a bit, and that is feedback. Okay, so we studied feedback when we talked about microinteractions. But feedback does what? Feedback reveals the what of a microinteraction. Anyone remember? Starts with an R. Yeah, go ahead and say it louder.
Rule?
Yeah, the rules. Feedback reveals the rules of the system, okay, or of a microinteraction. Who remembers the 3 types of feedback? Yeah.
Visual, haptic, and sound.
That's right. So when we're talking about visual feedback, we're talking about just things that are visual on the page, like some sort of a error message or something like that. We're also talking about animation. And then auditory, we're talking about speech. So could the system like speak something to you? Ear cons is a play off of the word icons. The ear cons just are like little, you can think of them as an auditory logo almost, like a little ding or a bling or a boom, any of those sorts of sounds. Use speech, you've got mail, those sorts of things. And then there's haptics, which are like vibrations coming from the device itself. Okay? So feedback helps bridge the gulf of evaluation. Yeah, was there a comment?
Just with the ear con, there's like the AirPods when you put them in, they make like a noise.
Yeah.
Would that be an ear con?
Yeah, that's all right. So yeah, so you put those in, and do you remember, does it go boodum or does it go boodum? It goes up, yeah. Going up is usually very positive. Going down is negative. So people who study this study speech and sounds, and I believe the word, I may be getting this wrong, but I believe one word is prosody. So it's kind of like baby talk, kind of like, R2-D2. You still kind of know what R2-D2 is saying, even though it's like unintelligible, like no words or something like that. So if you can like incorporate that into your system, it can create like a delightful experience where you don't actually have to listen to a recorded voice. You just listen to the sounds, and it's like you're communicating with it, just like with an R2-D2 or BB-8 or something like that. Another tool are conceptual models. And a conceptual model is like an explanation, usually very, very, very simplified, about how something works. So here's an example of a conceptual model, which is using the model of folders and files to talk about the way that computers work. Now, a conceptual model doesn't need to be complete or accurate as long as it's useful. In this case, folders and files is not an accurate way to actually describe computers. There's no folders in a computer. There's no files in a computer. We are just used to talking that way about computers, and it's a very useful conceptual model for us to help us interact with computers. So if you take it in a literal sense, that's not what's really going on, but in a metaphorical or conceptual sense, that's one way to talk about it that we find very useful. Okay? Conceptual models are also called mental models, and there's lots of literature. Here's an entire book just about conceptual models or mental models. So the basic takeaway here is that a good mental model will help you evaluate the system so that your users can understand it and reasonably predict the effects of their actions. Okay, so that's conceptual models. Now we'll talk about the gulf of execution and how to bridge that gulf. When we're trying to bridge the gulf of execution, we are trying to help users really understand how the system works and what they can do with it. Okay? And so some of the tools that we have to bridge this gulf include signifiers. So we've talked about signifiers before. Who can remind us all what signifiers mean? Yeah?
A label or an icon that indicates what something is or what you can do with it.
Yeah. It could be a little bit more general than a label or icon. It could be any sort of marking. But yeah, or it could even be the shape of a thing. But it is anything that, really any mark, or it could be even a sound, any sort of perceivable indicator that communicates the appropriate behavior to the user. So that's signifiers. There's also constraints. So constraints are these clues that tell us what is possible with the system. It kind of limits what we're able to do with the system. So the proper use of constraints really helps people understand how to better interact with the system And the better the constraints are of a system, the less the user has to learn and the less the user has to memorize. Because if it's very constrained, then the user isn't able to make a lot of mistakes. So as an example, if a button is disabled, well, that's a constraint that tells the user that in this particular state you can't do anything with this specific button. So it's constraint. And there's different types of constraints in the literature. There's like physical constraints, like a lock on a bike or something like that. There's cultural constraints and semantic constraints as well. But we don't need to get too much into that. Earlier in the semester, we learned about poka-yoke. Who remembers what poka-yoke means? Yeah.
Basically build your interface so that it's very difficult to make mistakes.
That's right. And poka-yoke is kind of a philosophy around designing interactions that actually bridges both the goal of execution and the goal of evaluation. Because if you have very clear feedback and a very clear conceptual model, it's much less likely that someone's going to make some error. But if you have really clear constraints about what you can do with the system, that will also make it less likely that the user is going to make some sort of error as well. So you remember the missile alert in Hawaii, that if there was better constraints around that system, it would have been less likely that that would have happened. So those are constraints. Mappings. So mappings are relationship between elements of two sets of things. This concept is kind of taken from mathematics. But in design, good mappings make it really easy to determine the relationship between actions and results, between controls and the effects of those controls, and between the system state and what's currently visible on the screen for the user. So here's some examples. So here's a regular stovetop. How many of you have a stovetop that's kind of like this? How many of you are always like turning on the wrong one? Yep, it's very, very common. And that's because there's not a very good mapping from the controls here to the which burner you want to actually control. So if you were to have a better system of mappings for this, you'd have something like this, where it's very clear that the orientation of the controls is mapped to a specific orientation of the burners. Okay, so that's a much better mapping. Here's another example. So here there's just a ton of lights. Basically, these aren't mapped to anything. There's no labels. There's just a bunch of lights, and I can guarantee that whoever lights these are, they're always flipping 2 or 3 on just to find the right one that they want to turn on. Something better. Well, let me ask you. What do you think would be better than this? What ideas would you have? Yeah. Something that, it maybe not be so practical, but you could do lighting with this sort of an interface, right? You could have light switches sort of, you could imagine a floor plan of the building itself with these little switches. Sorry that the image isn't so clear, but here's an illustration of it. Also not very clear, but you can get the idea of you're standing here where the X is, and there's a mapping of the lights to to the layout of the room itself. Here's another example of mappings that I'm sure you're all very familiar with. This is for just, some soccer game. These are kind of nondescript kind of buttons, right? But over time, these buttons have taken on certain conventions, and those who know the conventions can easily jump into a game and figure it out. But even if you are able to figure it out, you still will need to know, what some of the actions are that you're able to do. And so this is an example of mappings of sort of controls to some video game that has some sort of custom actions with the characters and things like that. But conceptual models also really help bridge the gulf of execution. One other principle that kind of applies to both that we've talked about is discoverability. Both discovering the state of the system, but also discoverability in terms of determining the actions that you can do with the system. These really help bridge the gulfs of evaluation and the gulf of execution. Okay, so that's understanding a little bit about goals and some concerns relating to understanding goals and understanding how to use design tools to help people accomplish their goals.